first example, we're going to be solving by isolating the variable. So in this case, our variable is the square root of x. So just like any other one-step equation, to isolate our variable, we're going to subtract -7 from both sides. And we're left with the square root of x equals 9. Now, the way we get rid of a square root is we square the square root, square the 9, and we get x equals 81. In example 2, we're going to be solving with radical expressions on both sides of the equation. This is actually pretty easy because what we're going to do is square both sides. And once we square a square root, the radical sign disappears. So we're left with 5x plus 11 equals x plus 5. Now we just need to get our variables on one side of the equation, get our non-variables on the other side of the equation, and solve for x. So we're going to subtract x from both sides. We're going to subtract 11 from both sides. These will cancel, and we have 4x equals -6. Divide by our coefficient, and x equals -6/4, or -1.5. In example 3, we're going to identify extraneous solutions. An extraneous solution is a solution you might get when you're solving the problem that isn't a real solution. The solution actually does not work if you were to plug it back into your original equation. So to start with, we're going to do n equals the square root of n plus 12. Now to start out, to get rid of the radical sign, we're going to square both sides. So then we have n squared equals the square root of the square of a square root. Just they go away, they cancel each other out. So we're left with n plus 12. Now if we bring everything on one side of the equation, we get n squared minus n minus 12 equals 0. Now, factor this out so that we can get two solutions. Factored into two binomials. We have n and n, and then we're going to have -4, or n minus 4, plus, or I'm sorry, n minus 4 times n plus 3. Now, we set both of these factors equal to 0. We have n minus 4 equals 0, and n plus 3 equals 0. Because one of these two factors, if not both, have to equal 0 because it's this factor times this factor equals 0. So one of these two have to be 0. Or both of them have to be 0. So when we solve this out, we get n equals 4 and n equals -3. Now, if we plug these two numbers back into our original equation, which is n equals the square root of n plus 12, we need to see see if these are actually equal to each other. So first, if we plug in a 4, n for n, we get n equals, or 4 equals, the square root of 4 plus 12. 4 plus 12 is 16. The square root of 16 is 4. So 4 equals 4. That checks out. That's good. Now to check the next problem, or to check our next answer, we have a -3. I'll write this over here. That would give us -3 equals the square root of -3 plus 12. -3 plus 12 is 9, so the square root of 9 equals -3. We get -3 equals 3. This is not true, which means -3, even though we got it as a solution, it's an extraneous solution. It's not one that works. So this is not a solution. So this problem only has one solution, which is n equals 4. Now example 4, we need to identify equations that have no solution in them. So to do this, we go ahead and solve the equation. In this case, we have the square root of 3m plus 8 equals 2. Subtract 8 from both sides, and we get the square root of 3m equals negative 6. Now to get rid of the square root symbol, we need to square this side, which means we'll also square the other side. So we get 3m equals 36. Divide by our coefficient, and we get m equals 12. Now if you stop there, you're going to say, okay, well, m equals 12, that's good. But it's not true, necessarily. We need to see if it works. Anytime you have radical signs in your equation, go back and check your answers because they might be an extraneous solution. It might not work. So go in and plug 12 back in for m. So you would get the square root of 3 times 12 plus 8 equals 2. 3 times 12 is 36, plus 8 equals 2. 6, the square root of 36 is 6, plus 8 is 14. 14 does not equal 2. So this is an extraneous solution. This means, since that's our only solution, there are no solutions to this problem. There is no number that we can substitute in for m to make this equation true.